Alright, so this is Interactive Advanced Concept 7, and what we're doing this week is we're showing the different electron domains with balloons. So the first one I have is a linear electron domain geometry, and there's two negative groups here. There's no lone pairs. An example of this would be a carbon double bonded to two oxygens. And then the next one that we have, Alright, so this one, there's three electron domains. There's three negative groups here, and this is a trigonoplanar geometry. So there can be either no lone pairs, so there can be three bonds here, or there can be one lone pair and just two bonds. So it'd be like two bonds, and then this one would be the lone pair up here. And the molecule type is AB2. And an example of this could be SO2. And when there's three bonded atoms, it's just the trigonoplanar, and then when one of these becomes the lone pair here, then you get a bent molecular geometry. Alright. And then the next one we have, there will be four. Alright, so this one, there's four negative electron groups here. What we call this is a tetrahedral electron domain geometry, and there can either be no lone pairs, so there's four bonded molecules, that would be like CH4, and the molecule type is AB3, and then when you take one of these away, you get a trigonal pure metal. An example of that would be NH3, and that would have one lone pair here. It's even possible to have two lone pairs in here, and then you'd get a bent tetrahedral molecule. So it'd be OH2. Alright, and then next we have five negative electron groups. Right. So this is five negative electron groups. The electron domain geometry is trigonal bi-pure metal. So here, and what this type of molecule is an AB4. So there's five different groups onto the one main molecule here. And the number of lone pairs, there can be 0, so everything is bonded, or there can be one lone pair, there can be two lone pairs, or there can be three lone pairs. What it refers to in the table 9.2 is one lone pair, and we have the seesaw shape. So it would be, if I just took one of these away here, then this would become a lone pair. And an example of that would be F4. And if we had all groups binded, then it would be the trigonal bi-pure metal. And then the last one, we have six electron groups here, six negative groups, and the type of molecule here would be AB5, and then so this with the 6 electron groups would actually be AB5. It's octahedral, and there can be 6 groups binded, there can be no lone pairs, and then it's octahedral. An example of this would be SF6, and it would look like this with everything binded like that. And then the next one would be just one group of lone pairs, so maybe this one became the lone pair, and it would be a square pyramidal. So an example of that would be BRF5, and then if we had 2 lone pairs, it'd be square planar octahedral. And an example of that is XEF4. Alright, so those are the main electron domain geometries that we've learned in this course and throughout Chapter 9. And just some examples of the type of compounds that form from those different groups. Thank you.